Doug Tallamy, and I'm impressed. With being the last talk, I thought the room would be empty. So impressed with your stick-to-itiveness. I want to talk about helping E.O. Wilson realize his greatest dream. He's had a lot of dreams in his life, and he's realized most of them, but he's, of course, E.O. There you go. E.O. Wilson, the most famous entomologist in the world, the only scientist to win 2 Pulitzer Prizes. He certainly knows how to wax eloquently, but he's recently written a book called Half Earth. His biggest goal, of course, is to save the biodiversity in the earth. And he's feeling desperate. He's not getting any younger. He wants to see some progress in his lifetime. So he says the only way we're going to sustain viable populations of biodiversity on this planet is to save half of it. So he calls it Half Earth. Biodiversity hotspots are not enough. I mean, he was integral in bringing that notion to us many years ago, and those are the areas of the world where we have most of our biodiversity. Efforts to save those, they haven't been all that successful, and it'd be great if we could save them, but it's not working very well. We're very good at saving areas that we don't care about, that we can't inhabit, like mountaintops, and we can save the deserts, we can save our tundra, but of course that's not going to be good enough. E.O. says we have to save half of the entire planet. Okay, that's a wonderful idea. But even the staunchest environmentalists are scratching their heads and saying, E.O., how can we do that? That seems preposterous. It's preposterous because we're wondering where all this conservation is going to take place. We already farm half of the planet, the terrestrial parts of the planet. You know, saving half the ocean, okay, we ought to be able to do that. But how about the land masses? Half of it is being farmed right now. We humans are pretty much everywhere. Our footprint is enormous, and of course we keep increasing the number of humans on the planet every single day. So where are the people going to go if we practice conservation in the typical form that we've practiced it in the past, which is having humans here and nature someplace else? And of course, we can't do that. That's not going to work. So the solution is to try a new conservation approach, and that is to have humans and conservation in the same place. We're going to do that by sharing the lands that we occupy, the lands that we live in, work in, play in, and to a lesser extent farm in. Let's just start with the areas that we live in and work in. So we've got to share these human-dominated landscapes with most of the other species around us. It's not going to work for all of them, but how might we do that? We have to. It's going to be easier than you think. We simply have to put the plants in our landscapes that are best at saving biodiversity. In the past, we have landscaped for aesthetics only. We're really good at doing that. So we've brought in plants from all over the world, primarily from Asia, and we plant them as ornamentals. But they're very poor at preserving biodiversity. We've also got giant expanses of lawn, which is absolutely terrible at saving biodiversity. So by putting the plants back in those spaces and using the most powerful plants that we have, we can save a great deal of biodiversity right where we live without moving out. Just to give you a quick example of how that might work, let's talk about my 12 by 12 experiment. Now, we've been looking at the impacts of non-native plants on food webs for the last, 12 years in my lab. Several published papers. You can go read them if you want, or you can do my 12 by 12 experiment. We always get the same answer, by the way. That's what 12 feet by 12 feet looks like. If you stake it out in your yard, you get to control the life that is going to exist in that space. You can keep it as lawn. You can get on your hands and knees on Wednesday and count all the biodiversity in that 12 by 12 section, and then it's not going to take you long, by the way. And then, of course, on Saturday when you mow it, you will kill it all. Or we can put a tree in that space. Let's put a white oak in that space. Now, that's one I planted from an acorn 14 years before I took that picture, which demonstrates that oaks grow, by the way. You hear landscapers say, oh, hey, don't use an oak. You won't live long enough to enjoy it. I'm enjoying it. Let's filling that 12 by 12 space very nicely. Let's walk around the perimeter of that tree and just at head height. We're not getting on ladders or anything. Just at head height, let's count the caterpillars that are on that tree, and let's do it on July 25th, 2014. 410 caterpillars from 19 different species. Let's go to a black cherry, about the same size, walk around, count the caterpillars, 239 caterpillars from 14 different species. Now, we're not working very hard to do this. That took me about a half hour. Now let's go to my neighbor's house. Neighbor moved in the same month that we did. We both have 10 acres. He had different plant choices than me. He really liked calorie pears. You might know them as Bradford pears, a highly invasive species from Asia. So he planted 32 of them. So the first thing we have to do is choose which calorie pear we're going to measure. Actually, the first thing we're going to do is make sure he's not home. Okay. Let's choose that one, walk around, count the caterpillars. I did find a caterpillar. I found one inchworm, one species. Then I went to his burning bush, another highly invasive species, 12 by 12 section, count the caterpillars. I got 4 caterpillars from one species. These are the stark differences between out-of-towners, between plants from someplace else that have not been here long enough to develop the specialized relationships required to support food webs, and our really productive native plants that have been here for eons. Let's just elaborate on that a little bit. Why can't my neighbor's plants support the biodiversity that we need? Oh, don't make a face. That's a beautiful spun glass slug caterpillar. It's my favorite. First of all, why am I talking about caterpillars? They are such an essential part of food webs. Birds take thousands of caterpillars to rear one clutch. So you need to have plants that are producing the caterpillars that are going to support reproduction farther up in the food web. Well, most of these caterpillars are host plant specialists. That means that they can only develop on just a few lineages of plants that share a common cocktail of chemical defenses. Plants don't want to be eaten, so they capture the energy from the sun, and they want to use it for their own growth and reproduction. They want to defend their tissues, so they put nasty chemicals in there, secondary metabolic compounds that make those tissues either bitter or downright toxic. Insect can't eat those plants unless they develop the adaptations to get around those chemicals. And that's the key. 90% of our native insects are host plant specialists. They can only develop on the plants which they share a coevolutionary history. And my neighbor's calorie pears are not going to do it. As a matter of fact, on his 10 acres, every single plant he has planted is a non-native plant. So he's supporting just about no biodiversity on his 10 acres, and that's what we're doing around the world. When we go and to the nursery to pick up a plant, we're thinking about aesthetics only. We've come to see plants as decorations, and they are decorations. They're beautiful, but in doing that, when we buy plants and only look for their beauty, maybe they can be a screen, an anchor, or a focal point, we're not thinking about their ecological value. What ecological roles do they have to play at home if we're going to save biodiversity at home? But we could. As a matter of fact, we could reestablish ecosystem function all over the place if we chose the right plants. They could have food web value, they could protect our watershed, sequester carbon, help the pollinators, do all of those things right at home. Why do we need insects? We need insects because they are critical components of food webs. They also drive the ecosystems that support us. And back to EO, he said decades ago that a world without insects is a world without biological diversity. And a world without biological diversity is a world without humans. So this is why this is a message that everybody on the planet needs to pay attention to. We need to put the insects back on the planet. In terms of food webs, all spiders eat insects. Or they eat other spiders that ate insects. We have an awful lot of predatory insects that eat the insect herbivores. If we lost the insect herbivores, we'd lose all those predatory insects, and they themselves are part of food webs. If we lost our insects, we would lose our frogs, our toads, all of the amphibians. They all eat insects. So do our lizards, so do our bats, so do our birds. 96% of our terrestrial birds are rearing their young on insects, not seeds and berries. So again, you'd lose all your birds. Our rodents eat insects. Everybody thinks they eat seeds. They eat insects because they're really good food. They do eat seeds, but only when they can't find enough insects. Pound for pound, some studies have shown twice as much protein in insect meat as there is in beef, and they're loaded with organs in their abdomen called fat bodies, high in lipids that allow these little guys to grow quickly and reproduce quickly. And if you're a mouse, that's what you need to do because there's so many things that want to eat you. But it's the same reason that larger organisms are eating insects. They're just really good food. The skunk is digging up your yard to get the grubs in your yard. Possums eat a lot of insects. Raccoons eat a lot of insects. Even things we don't think of as insectivores eat a lot of insects, like our friend the red fox here. 25% of its diet is insects. 23% of a black bear's diet is insects. So it doesn't matter how big you are, you need insects. Even if you don't eat insects, you need insects. This is a sharp-shinned hawk. It's a bird predator. And you might think you can have sharp-shinned hawks in your neighborhood, even if you get rid of all the insects, but you can't because the birds that this guy's eating needed insects to become birds. So he needs them indirectly. So does the garter snake. He's not eating insects directly. He's eating the frogs and toads that ate the insects. So what we have to do, we have to think about raising the bar about what we're asking our landscapes to do. Now, in the past and the present, we ask them to be pretty. We demand that they be pretty. Okay, they can be pretty, but they also have to support life. If we don't support life where humans are, it's going to disappear. Forget about saving most of the biodiversity. We've got to support it where we are. They have to sequester carbon. You know, we've got way too much carbon in the atmosphere. A third of it has come from the plants that we have removed from the planet. We've lost more than half of our forests. All that carbon's up in the atmosphere right now. When you put the trees back on the land, or any of the plants, not only do they build their tissues out of carbon, they start pumping carbon into the soil. The soil scientists have been very quiet about this, but now they're telling us our soils can sequester 7 times the amount of carbon that's in the atmosphere. What's putting them back in the soil? It's plants. We have to clean and manage our watersheds. We all live in watersheds. Nobody has the right to destroy their watershed. But every time we put a big lawn in, that's exactly what we're doing. So we want to cut the area of lawn in half, enrich our soil with carbon, support those pollinators like you just heard. Here's a house down the street from me. And it's not doing any of those things. It's celebrating lawn as a status symbol. We're really good at doing that. So we need to cut the area of lawn in half. We have an area of lawn in the U.S. the size of New England, 45.6 million acres. If we cut that in half, let's make the math simple, make it 40 million acres, we can create a new national park. We can do it right at home, so we can call it Homegrown National Park. And it'll be bigger than the Adirondacks, plus Yellowstone, plus Yosemite, Grand Tetons, Canyonlands, Mount Rainier, North Cascades, Badlands National Park, Olympic National Park, Sequoia National Park, the Grand Canyon, Denali, which is huge, the Great Smoky Mountains. You add up all those parks, still less than 20 million acres. So we can save nature, but only if we learn to live with it. And I want to leave you with one example of how easy it can be. It turns out that residential neighborhoods in South Florida accidentally saved this beautiful butterfly, the Atala butterfly, from extinction. How did that happen? Well, it's a lycaenid butterfly, little species. It's beautiful as an adult, it's beautiful as a larva, beautiful as a chrysalis, but it's an extreme host plant specialist. Only develops on one species of plant, the kunti, which is also, it's a native cycad in South Florida. Kunti has a lot of starch in its roots. In around 1900, somebody decided they would start a starch industry based on kunti roots. I think it was the 1908 census in Miami. 80% of the people identified their occupation as starch gatherers, and they did. They gathered all the starch. They eliminated kunti from the wild. There were a few plants left in gardens, but it was extirpated from South Florida. So, of course, if you lose the only host plant for this butterfly, you're going to lose the butterfly as well. Well, in 1973, we got the Endangered Species Act. There was a desperate attempt to find some Atala populations so they could get them labeled as endangered, so they get some federal funding to try to save it. People looked all over Florida. They couldn't find any. So instead, they got it officially listed as extinct. But about that time, the horticultural trade recognized kunti as a valuable landscape plant. It's a low-growing evergreen shrub that does well in the sandy soils of South Florida. So they started to promote it. And now you have these large plantings of kunti pretty much everywhere in people's yards and parks. And look who showed up again. Now, I used to say nobody knows where they came from, but it turns out there was a remnant population on one of the keys, which is now out colonizing these residential plantings. Kunti is still extirpated from the wild, but it's in these plantings. So what I really like about this idea, or about this example, is that it truly was an accident. They never got the Atala listed as an endangered species, so they never got one dime of conservation money. The only thing that changed is that we added one plant species to the palette of plants used in typical residential landscaping. And then the butterfly saved itself. So this shows it's a really powerful form of conservation. If we could save this butterfly by accident, by changing the way we landscape, think what we could do if we made conservation a conscious goal of landscaping. I think it's going to work if we start soon. Nature has proven to be a lot more malleable and resilient and forgiving than I ever thought she would be. I can guarantee, though, she's not endlessly forgiving. There's a point at which she will not bounce back. But I think she's going to give us one more chance. Thank you very much.